Hello everybody, this is the solution video to problem 2 from quiz 4, and this is a question about partial fractions. So we're not actually going to be doing the full partial fractions in this problem. Instead, we're simply going to be looking at the form of a partial fraction decomposition. So let's read the problem. It says Timmy is trying to find a partial fraction decomposition and writes down the following. So let's see. So we have this quadratic in the numerator, and in the denominator, it looks like we have a cube of a linear term and then another quadratic. We might ask, can we factor this quadratic on the bottom? And the answer is going to be no, which we could see pretty quickly by just looking at these numbers 2 and 7. So if we compute 2 squared minus 4 times 7, right? This is coming from the quadratic formula, right? B squared minus 4ac. Well, okay, the a over here is a 1. That's why I didn't include it, right? There's your b, right? 2 squared, minus 4 times a, that was a 1, times c, which is 7. Okay, 2 squared is 4. 4 minus, let's see, 4 times 7 is 28. This is less than 0. That means if you were using the quadratic formula, you'd be ending up with a square root of a negative number, right? That's not going to have a real root. So you're not really going to be able to factor this to get two real linear factors. So it is what it is, right? It's a quadratic. And what Timmy thinks is that you say, well, look, you have s plus 1 cubed, so we break that up. And then we have this quadratic, so we break that up, and you put constants on top. And this is a very typical mistake, right? We're seeing this all the time on tests when people don't understand how the partial fraction decomposition works. So our goal here is what? Well, let's see. Timmy runs into a problem when trying to solve for a and b. Yeah, right. That's actually going to happen. All right. You know that you've done this wrong if in the next step you try to find a and b and you get things that just don't make any sense. All right, so we want to help Timmy by writing down the correct version of equation 1. All right, so you notice over here on the right, there's this 1. This is how we indicate an equation we want to refer back to. All right, but then we let Timmy finish the problem from there. So we're going to, we know, get constants, right, when we try to do a partial fraction decomposition, and then usually have to solve for those constants. And the instructions here are telling us, don't solve for the constants yourself, right? It's a long quiz. We don't need to spend our time doing things that it tells us not to do. Okay, so what should be the correct decomposition? So let's copy the problem down. So we have s plus 1 cubed, and then we have s squared plus 2s plus 7 in that denominator. Our numerator, of course, was 7s squared plus 4s minus 9. Now, there are 2 pieces on the bottom. That's true. And Timmy's mistake, right, was his first mistake anyway, was in not recognizing that the first piece, this s plus 1 cubed, is a repeated linear factor, right? And he said, well, it only occurs once, s plus 1. Yeah, it's repeated, though, because it's cubed, right? It's really s plus 1 times s plus 1 times s plus 1. And when that happens, you're going to need to have one summand for every number you have up here, right? So that's a 3, okay? So that means you're going to need to have 3 summands, okay? So let's just start here with the 3 summands corresponding to s plus 1. The first one will just be an s plus 1 in the denominator, all right? The second one, we go up a power. We have s plus 1 squared. And then finally, the third one is the s plus 1 cubed. So Timmy was wrong. The first reason he's wrong is because he only did a third of the terms he needed to have. All right, and then we can put some constants up here. Okay, and I know it could be A, B, or C and nothing else, right? It can't be any, there can't be any sort of S because I know the numerator has to have degree, which is smaller than that of the denominator. And the degree down here, right, is 1. Okay, this is s to the 1. Now you might say over here, this now is degree 2, and over here, this now is degree 3, and that's true, but because, again, we're in this repeated linear factor case, all right, the partial fraction decomposition theorem says all we're going to get, right, we can actually just use constants in the numerator. Okay, so that handles the first problem. The next problem came in the quadratic side. So Timmy is right. We do need to have a summand that corresponds to this so-called irreducible quadratic, s squared plus 2s plus 7. However, Timmy made another mistake in that he only allowed for a constant in the numerator. We can have any polynomial, in fact, which has degree smaller. So for example, we could have a degree 1 polynomial, right? This is a degree 2 polynomial in the denominator. So actually, we need something that looks more general. We need something like ds plus e. Okay, and that's just that annoying piece of having some irreducible quadratic in your denominator. The good news is that no matter how nasty you make the bottom, these are the only cases you really need to worry about. If you had a cubic, it's always going to be possible to factor it down to a linear and a quadratic, right? Or even 3 linear pieces, right? That could happen. And cubic isn't special. If you had 4th power, 5th power, whatever higher, you could always break that down into linear pieces and quadratic pieces. So this is all you need to actually know for doing any partial decomposition, any partial fraction decomposition, right, over the real numbers. All right, so there we go. Now, the next step is not to solve for A, B, C, D, and E, because again, remember, we were told not to solve for those. We're going to let Timmy work that out. All right. Now, if you do want to see me working out some constants, check out the next video.